So please allow me to welcome the panel. That will be accompanied by Bray, who is the competition's lead at Zindi, which I think is an understatement. I know Ami for one of the best data science girls at Zindi. So we have Nicolás Lopez from the DeepChain and BioAI lead, and we have Tristan Carnias, research engineer at InstaDeep. We have Darius, data scientist at Zindi. So these are all gathered here to talk about the technical elements of the challenges. So if you have any questions that we haven't yet answered, please feel free to share them on the Discord channel, and then we'll answer as many as we can. Remember, the walkthrough videos for each of these challenges are currently available on YouTube, but also on the links provided on Discord. You could also find them on the challenges pages. So let's get stuck into this technical conversation. Amy and colleagues, spotlight.
Great, thanks so much, Sam. It's such a delight to be here. We've been planning these challenges for a couple of months now. We're so happy to see them out in the wild. I'm going to start the session off by answering a couple of questions that have come up in the discussion, in the Discord and in the discussions. I'm then going to ask Darius just what top features he would use in the beginner challenge. And then I'm going to address Nicolás and Tristan for some help on the advanced challenge. That's just how we're going to run this session. I've got two screens here, so bear with me if I get confused. If you have not signed into a challenge yet, the password is hashtag UmojaHack Africa 23. Please take note of those capital letters, and you can just copy paste that into the channel. I'm going to make a submission to the cryptojacking detection challenge, but this process is the same for all the challenges. So please make sure that you are logged in. I'm currently logged in as Zindi, so I can see the little Zindi icon here. You'll be able to see your own. Over here, we have the submit button, and this is where you're going to submit your predictions. You have 75 submissions for the day, which means 75 for today and 75 for tomorrow. You're going to choose a file. I've already run this model and it is over here. And I can make a comment. Oh. Then you can hear me. Happy that that's okay. My submission. If you are having problems making a submission, please make sure that you are logged in at that top. And there we have our score. You can now go and see yourself on the leaderboard by clicking leaderboard. I'm currently ranked number 98. I'm so glad that there are people at the top of the leaderboard. Congratulations to Victor or Professor, who's currently number 1. Just some insight into this challenge. Rumor I've heard is that Cat Boost is going to be giving you the best score. So if you're playing around with models, I recommend testing out Cat Boost, seeing if there's any parameters that'll get you a nice 0.96. What code can you code in? At Zindi, the data science team works in Python, but if you are comfortable working in R, please can you create your solutions in R and submit them, or any other open source language. An example of a not open source language would be MATLAB. So please don't work in MATLAB, but preferably work in Python or in R. If you're using Colab, the free version, you should be able to run all these notebooks. The beginner notebook should take about 20 minutes to run, but if for some reason it's going really slowly, I recommend maybe running it cell by cell and seeing what happens. I see no questions have come in yet, more questions regarding the beginner challenge. So I'm just going to ask Darius as he prepared the challenge. Darius, what features would you be focusing on this challenge?
Thanks, Amy. That's quite a good question. With this data, we have a lot of features. There are about 76. So some of them are good for the models, but others are not adding a lot of information. So a good thing you can do is build a simple model or a complex one, and then view the top features for that model and see how the models are ranked, how the features are ranked, and then you can select the top. If you have prepared or if you have created new features, you can use Boruta. There's a library in Python called Boruta that can help you to choose the best features for your model.
Darius, how do you spell that library?
It's Boruta with Boruta.
TA. Boruta library. Oh, there we go. We will put this in the chat. That's such a good recommendation. Thank you. As well as many features, there's many missing values. What would you be doing with those?
So when it comes to building models, it's an iteration process, which means you have to try different ideas and then choose the one that best works for a certain problem. So my recommendation is you can build a model without filling in the missing values and then see how the model performs. On the other hand, you can try to fill in the missing values using the mean, the median, or you can use to fill the missing values with like a large number and see which fit engineering works best. So it's a matter of trying out different ideas and then picking up the one with the best performance.
Thanks, Darius. As this is a weekend of learning, if you have found something that works or something that doesn't work, which is normally just as useful, please do share that on the discussion board or in Discord so everyone can learn from you. Even if it's as simple as, I found this feature to be really useful or really not useful. We've just gotten a question in, what happens if my submission file is not scoring? If you open up your submission file, let's scroll down to the bottom. In this notebook, when we create the submission file, you'll see that we set the index to false. This is very important because in Zindi, we only take in these two columns. So the ID, latitude, year, and week column, and the emission column. If you forget to set your index to false, it will take in this column as the first column. And it will say that you're missing IDs when in fact you have them. Our scoring system is just counting the wrong column. So before you panic, double check that. I'm now going to move over to Tristan and Nicolás. Tristan, Nicolás has shared a picture with me. Would you like to tell me how you got into Rubik's Cubes and why you thought this was a good challenge?
Sure. So welcome, everyone. So I guess my interest in Rubik's Cubes dates back around 15 years now, from when I first started as a student and felt like I wanted to acquire some of the habits that I would associate with studying maths, and a Rubik's Cube seemed like the obvious choice. So I began with the basic one, which is the one that most people are aware of and is the one that this challenge is about. But over the course of a while, I spent actually quite a lot of my student loan, as it so happens, on an increasingly large collection of cubes, which now is on a shelf in the next room. So yeah, that was my initial interest, and reinforcement learning, which is what this challenge is about, is actually a very nice tool for solving problems like this, which are decision problems where at every stage you have to make a decision about which face you're going to turn and how much you're going to turn it by in order to achieve an objective, in this case to restoring the cube to its original solved state.
I recommend not spending your student loans on Rubik's Cubes and toys, but each to their own. Tristan, what applications are you currently working with reinforcement learning at InstaDeep? Like, sure, this is just solving a Rubik's Cube, but where does reinforcement go from here?
Yeah, it's a good question. So reinforcement learning sort of made its start in games and other situations where it's fairly easy to sort of assess how well you're doing and sort of give a score. So the most famous example that really brought reinforcement learning into the mainstream was solving Go, which happened back in 2016. But since then, reinforcement learning has been applied increasingly to some more sort of relevant industrial applications. And some of the challenges that we work on at InstaDeep with reinforcement learning include electronic circuit design, which is the project that I'm principally working on when I'm not doing this. And also bin packing, which is for logistics when we're trying to fit a bunch of items into as small of a container as we possibly can.
Wow. Amazing how it can go from something so small like packing bins to like chips. Just amazing. One problem that I keep seeing come up in the discussions is a problem with the tensor board. Could you explain how to first problem before we go in there, something that Nicolás had to walk me through, and it stems from me not being able to read. But you need to run your first two cells, which is just importing your libraries. You then need to restart your runtime. So by restarting your runtime, you just need to click runtime and restart. From here, you can continue to run your notebook. So that is the first error you'll encounter. The next error encountered, and I'm also facing it, is that I can't scroll. Yeah, can't use TensorBoard. Nicolás, how do I get around this, and how do other users get around this?
Yeah, I mean, this is many users are encountering the problem that they cannot load the TensorBoard in Jupyter. I guess this is something weird because it's browser dependent. We had no problem with that during the demo video. So what we suggest to do is, well, either you try to fix it, which it might be a bit challenging, but maybe try a different browser. That would be a good one. But if not, if you, Amy, click on the left where the folder is, we can go to actually where the checkpoints are. Yeah. So if you go up, you will see the checkpoints are in the root folder, and then inside Ray results. So this is where like the algorithm is storing the checkpoints. So you could potentially download this folder and then load TensorBoard locally on your own machine and have a look at the results there. I know it's not the ideal solution, but it's a hackathon, and either we try to fix it or we have this workaround.
Yeah, what I'd say on that is that like running TensorBoard locally should be very lightweight compared with the actual training that's being done. So even if you don't have access to the world's best computing resources, you should be able to run TensorBoard once you've installed it without any real problems. And if you have any difficulties, then like please ask on Discord or look online. It should be fairly easy to understand. One of the other errors that was coming up a lot when people were trying to run this notebook was trying to restore from a path. So I just want to make it clear that like the paths that are in this notebook are the example paths that like I generated when I was running the notebook, but these obviously only make sense on my local machine. If you're doing your own training, then there will be like an associated path, which is printed out at the end of the training loop. So when you run a cell, you'll see the path that you need to point to at the end, and you'll need to copy that string and potentially also a specific checkpoint within that directory as the path to restore from in order to, for example, continue training or to evaluate and generate your rollouts. I noticed that some people have already submitted some scores, and there's a current leader of 0.17, which is very good. I can give some advice if people are interested on like how to potentially improve their score. So actually, while this panel was going ahead, I was running some training in the background. I managed to achieve a score, not boasting, but I managed to achieve a score of 28%. So I can maybe give you a brief insight into how I did that. And it looks like someone's getting close though. Okay. So what I did was I used something called curriculum learning, which is when we talk about it a little bit in the video, but just to give a brief overview, we start with trying to solve an easiest possible version of the problem, which would be when you only made one turn from solved. So I did actually bring a cube here just in case it's at all useful. So we make a single turn from solved, and then we ask the agent to work out what sequence of moves to do in order to solve this situation. That should be fairly straightforward. At the beginning, the agent won't be able to do it because it will be making completely random choices, but hopefully in a small number of iterations, say 10, the agent should learn fairly consistently to be able to undo the result of a single scramble. And then from there, if you present it a situation where instead of having just one turn applied, it's had two, so like that, this is now a slightly harder situation, but given that the agent already knows how to solve cubes which have only had one move performed to them, it should be more feasible for it to work out how to solve this situation. And if you keep on gradually advancing the difficulty and giving more and more iterations each time, as you increase the number of scrambles, then eventually you should get to the point where the agent is fairly reliably able to solve even more complicated situations. And obviously playing around with the details of like how steeply the curriculum advances. So like how many iterations you do on a certain number of scrambles before you advance to the next highest value, which is going to be a more difficult situation, is something that is going to require a little bit of experimentation. And the only advice I can really give is to try different suggestions. But an approach like that should get you off the ground. And that would be my suggestion on how to start.
So there is a variable in the training loop there, which is number of scrambles on reset. That's the variable we need to change to control this, right?
Yes, that and also the number of iterations to train from. So I would suggest to run this first with number of scrambles on reset equals to 1 and number of iterations equal to, let's say, 10, and no restore path. And then later, when you want to restore that training, you set the number of scrambles to 2, you increase the number of iterations to 20, let's say, so you want to do a further 10, and you pass the restore path as the output of the 10th checkpoint that the previous training generated, and continue iteratively like that. Another thing you could also try is playing with the actual model itself. This is a little bit more of an advanced suggestion, but I've coded an example model, which you can find in the code if you want to look at exactly how the model is structured. But I'm not claiming that that's the best possible model out there. You could experiment with some other alternatives if you think that there's a way to encourage better learning. And if people are very ambitious, then they could try and change the actual way in which the training is done. So this uses an algorithm called PPO, which is, in my experience, the easiest and most stable algorithm to get started. But there are a whole bunch of other algorithms out there, both within the RLib ecosystem that we've implemented here, but obviously you're free to use anything that you like, which may well perform better. So that I will leave to people to investigate.
Amazing. Thank you, Nicolás. You mentioned how to find the path. I'm just going to show you how to do that because, again, I didn't catch it. So this is the first time you train your model. Once it's finished training, if you scroll down to the bottom of the output, in the last line, we have our path, which is saved in root. So you go into your content, you'll see the Umoja folder. But if you go down to root, here you have your Bray results, your PPO model, and here you have your checkpoint.
Yeah, and so just to clarify, the path that's printed at the bottom is the parent directory where all of the checkpoints are found. And this is the path that you would want to give to, for example, TensorBoard if you want to see how the whole of training is going. But if you want to restore from a particular checkpoint, then you will need to give the directory to the checkpoint within that directory. So within each, sorry to interrupt, Amy, but within each run, particularly one that's actually finished, which doesn't look like this one has, you should be able to find like as many directories as there are checkpoints saved, which will normally be the number of iterations that you've been training it with.
Which in the first model is 2, and in the second model, I think it was 4.
Yes, although it will be only 2.
Yeah, in the starting notebook, it was that. Sorry.
No, 1 minute left, and to each of you, just want to give us a well wish as we say goodbye.
Sure. Well, yeah. As I said, good luck.
Any last words? Oh, Tristan.
Yeah, good luck. As I say, like the scores that are being achieved so far, in excess of 20%, are pretty good. As I say, I've managed to achieve 28%, which I was pretty happy with, but it looks like I might be getting beaten before too long. So yeah, good luck, everyone.
Yeah, good luck, everyone. I mean, don't be scared of reinforcement learning. This is an excellent challenge to get started with it. We are sponsoring the challenge, and the person who gets first place in this will have in this challenge will have the right for an interview to InstaDeep if you are willing to start a career in reinforcement learning. So good luck with that, and looking forward to meet the winners as well.
Sure.
Great, thank you so much. Back to you, Sam.
Wow, that was really, really eye-opening. I think, like I said, there is like technical experts at data, but also the features that have been in it. So I think I hope that was really helpful. I also believe that the questions that you have posed have been answered. Thank you so much, Amy, Tristan, Darius, and Nicolás for that wonderful session.